With this exercise, we'll see how we can use a histogram to answer some questions about a set of data. So the first question here, which height category has only 6 males? So we can look over here on the frequency side. So the frequency is always on the left vertical axis of a histogram, and then the horizontal axis has the different categories, and in this case the categories are height measured in centimeters for several male subjects of the study. So it says, which height category has only 6 males? So to answer that question, we can just go up to where 6 is on the frequency scale on the left side there and kind of draw a horizontal line across and see which one of these bars in the histogram has a height of 6. And we see it's this one that goes from 184.6 centimeters to 188.1, and so that's the category that has only 6 males in it. The next question, what is the most common height category? So the most common one is the one that occurs most frequently. So on the frequency scale, we find the highest bar, and it's this one here, associated with 177.6 to 181.1 centimeters. So that's the category that is most common then. The next thing is what is the largest possible height in the data? And so if we notice, all of our labels have a square bracket on the right side and a curved bracket on the left side. So that means they include the right endpoint and they exclude the left endpoint of each of the intervals. So the largest one is off to the right because x increases with the right, and we see it's 195.0, so that's going to be 195 centimeters as the largest possible height in the data that this histogram represents. So moving along, we have another histogram here of ambient test temperatures from space shuttle launches back in the day. So the first question, describe the shape of the histogram of test temperatures by circling one option below. And so we can see there could be skewed right, skewed left, or uniform. So when we look at it, we notice there's a whole lot of data points that are between 68 and 80 degrees up here. There's not very many much more than that, but there are several that are strung out here to the left all the way down to 28 degrees, between 28 and 33 or 34 degrees down here. So they're kind of strung out to the left, so we would say that the distribution is skewed to the left, or the histogram is skewed to the left. The next question, is the histogram mound shaped? So we notice it kind of slowly increases on the left up to this big bar, and then it does come back down on the right side. So it makes this little mound shaped over here. Even though it is highly skewed to the left, it is still mound shaped because it comes back down there on the right side. So yes, it is mound shaped. Next question, using the information in the histogram, estimate the median height. So this is a little bit of a typo though. It shouldn't say height, it should say temperature, because this is a histogram of temperature. So we should be thinking temperature. If you use the histogram up above, then you would be paying attention in great detail. Good for you. But the same principle is going to apply. So using information in the histogram, estimate the median height. Well, we've got to know what the median height is. So the median height is that data point that is in the middle of the data when we list it from smallest to largest. So this histogram here kind of shows from smallest to largest all the categories, and it tells us how many are in each category. So if we use that information by labeling each of the categories with their height to make it a little bit easier, so we can count off how many are in each category, we get some labels up here. So this one's like 2 high, this one's 6 high, and if we're counting into the middle, so that's 8, so we should count in from this other side to get up to 8. So there's 1 here, and then there's 2 here, and then there's 2 more. So it gives us 2 plus 2 is 4, plus 1 is 5, so we're still not up to 8. So the next one has a height of 3. So now we're up to 8, so we're kind of balanced on each side now. And then what remains here in the middle, this one's got 4. So there's 4 here, and then there's 4 more right here, right? So that would balance out, but then there's these 3 up on the top. We could think of them as being in the top of this bar, right? So somewhere in this bar is where the median, the middle, is. So it goes from 68.6 to 74.3, and just to estimate the median height, the estimate would be a specific number, so we can just take the average within that bar. So we take 74.3 and 68.6, divide by 2, we get the middle, 71.45. And since we're estimating the temperature, that would be degrees Fahrenheit. And any value in this interval here would be a valid estimate for the median height, but not the endpoints, because the endpoint here, 68.6, is excluded. It is not in this interval. And the 74.3 is right at the edge here, so it would be some other value that's within that interval. Okay, next question. How many times was the test temperature 57 degrees or below? So if we go find 57 degrees on our temperature scale, which would be right here, how many times was it 57 degrees or below? We just count up the frequency for everything less than or equal to 57 degrees, which is 2 plus 2 plus 1, which gives us the 5 times that we had a test temperature of 57 degrees or below. And then finally, how many samples were used to make this histogram? So we looked at the frequency count. We already stuck them on here after we read them off the graph, the vertical axis over here on the left, and we can just add them all up, and we see that they add up to 27 samples that were used to make the histogram. And that's it. That's a short little overview of questions, some example questions we can answer about a set of data using a histogram.